Untitled here, welcome to another Minecraft Monster tutorial. Today I'm going to teach you how to add network messages to the game. So this is for our block breaker, because at the moment our capability which we added last time doesn't sync with the client when we need it to, which is irritating. So what we're going to have to do is we're going to use a simple IMPL wrapper to create our own network messages. So we're going to add a new package called network, and inside here we're going to add our messages. So I'm going to call the first one, we're going to add two today. So one's going to send it to the server saying, hey, can I have the information about the work done? And the other one's going to send it back to the client saying the work done. So packet, and it's going to be get work, get worker. Because I'm going to get the get work done and also the max work done. So we're going to get the worker, and this is going to be a new iMessage. Like so. That's going to make us add some methods. There we go. We're going to have a private boolean to begin with. So private, I can spell private. And it's message valid. And what we're going to have is a default constructor. That's when we register it. I'm going to set message valid to false, if I can spell today, and that's false, so the message isn't valid. And 2 bytes, if it's not valid, we're going to return, like so. So if it's not valid, we're going to return the message. That's just to make sure that our message is okay. And for the from bytes, I'm just going to add a try catch, and it's going to get index out of bounds exception IOE, where we're just going to do the logger, so utils.getLogger.catching and return, and this dot message valid equals true. So that's how our message will defaultly be set up. Then we're going to add the variables that we're going to send. So what I'm going to send is a block pos of the tile entity, so pos, and I'm also going to send an enum facing, and it's just a side, so that's for when we use the capability, because we can actually have it for each individual side has a separate capability. So we're going to add a public packet get worker, and inside here we're going to take our block pos, and we're going to take our enum facing side, and then what we're going to do is we're going to do this dot pos equals pos, and this dot side equals side, and I'm going to say that the message is actually valid, like so. So in 2 bytes we're going to write all of our data to our buffer, and it's what the buffer is what is actually sent. So there's quite a few things that we can do this. So first thing, we're going to need to write our block pos, so it's actually just 3 int. So going to write an int, and it's pos.getX. Going to write another int, and that's if I can spell pos.getY, and we're going to write another int, and that's pos.getZ. And also we're going to write the enum facing. Now enum facing can't be written like anything because it's an object. But what enum facing does provide is a method called getName. I'm going to use getName2, which returns this dot name, but doesn't override it. So we're going to write this. Now it's easy for us, but if it's going to write a string, we have to write out the byte data. So what we're going to use is byte buff utils is a utility class. And what we can do is we're going to write the string to the buffer, and it's this dot side dot get name 2. And then we wrote all of our data. We now need to read all of our data. So this dot pos equals, and what it's going to be is a new block pos, and it's buff.readInt. So it's reading the first x value, so buff.readInt again, the y, and buff.read, forgot the dot readInt again for the z. So you have to do it in the order that you wrote it to the buffer. And then this dot side equals enum facing dot by name, and it's just going to be byte buff utils dot read UTF-8 string from the buffer, like so. So we've transferred all of our data. We need to actually handle this message. So what we're going to do is have a new class inside of the packet, and I'm just going to call it handler, and this implements a iMessage handler. Now what we put here is what we're going to actually receive, the message that we're going to get, and that's packet get worker, and that's what we're going to reply. We're not going to reply like the way by returning. We're going to reply a little bit differently, and what we're going to have here is just a method process message, and this is going to take in the packet get worker message and the message context ctx, like so. We're going to fill that in a bit. So what we're going to do is we're going to check if the message is invalid and side context.side is not equal to side.server. So it's not the server side. We're going to return null. We don't want to do anything because it's on the wrong side. It's not going to do anything. Seeing as it's on the right side, now we need to actually process the message. Now we could just process the message, but what we're going to do is we have to add it to the current thread. So we're going to do fml common handler dot instance, and it's get world thread from the net handler. We can get from the context.net handler, and we're going to add a scheduled task. We're going to use is it Lambada? I don't know how you say it. And we're going to use that again, and that's just going to call process message. And we can get rid of that, like so. We've added this method to as a task to the server. So what we're going to do here is we're going to send a message back. But we're not going to do this yet because we need to actually get the message that we're going to send back made. So packet return worker. And like any other message, we're going to implement iMessage, like so. We're going simple. And what we're going to do is we're actually going to write the data. So what we're going to have is the cooldown, and we're also going to have a private int for the max cooldown, as you would see in the worker over here. Cooldown, max cooldown. We're going to send this information. So what we're going to do is make sure we write the information. So we need to write the information first. So this buff.write. Now, there is actually something that I forgot, because the way we're going to update the values for us is we're going to use a bit of Java reflection. So we're going to have two fields in here which we're going to update with the method, but we need to say what the fields are called. So we're going to have a private string class name, like so. And we're going to have a private string, and it's going to be cooldown field name, and another private string, and it's max cooldown field name, like so. And we're going to have to take these in, so string class. Don't forget to write all that data, so byte buff utils field name, and guess what? We're gonna have to do it on the other message as well. So public packet get worker, and we're gonna need to take an int for the cooldown. And we're going to head back over to here, get the rest of this from up here, put that in there, and need to read and write. So we've wrote all the data. We need to now do our handler, so public static class handler. We need to handle the client side message, so iMessage handler. The message that we're going to get is packet return worker, and we're not going to return anything back to the server because this is going to end here. So add our implemented methods, and in here we're going to have a process message. Again, this is going to be packet return worker, and that's message. Now we're not going to use the message context for this one. Now, like the last time, we need to check if it's not valid. So if message dot isn't valid and the context.side is not equal to side.client, so not on the client side, we're going to return null. Now, seeing that we're on the client side, we can actually use client side methods, so we can use the Minecraft class. So if we take a look here, it is actually client side only, this class. So Minecraft.get Minecraft dot, and it's add a scheduled task like last time. And inside here, we're going to use a bit of Lambada again and process the message like so. So in here, we're actually going to update that field. So what we're going to do is use a try catch exception and what we're going to do is just use the utils.getLogger.catching in here. Now what we're going to do is we're going to get the class that we are going to set the value in, and that's equal to class.forName and its message dot class name. So we're going to get the class from the class name. We're going to get the field, so this is going to be the cooldown field, and that's equal to class.get declared field by the name of message dot cooldown field name, and we need to import this. Control Shift O. We're going to import it from java.reflect.field. We're going to copy and paste this, and this is going to be the max cooldown field. So just change this to max cooldown field name. So we've got the fields. Now we need to set the value. So we're going to do cooldown field dot set int. The first parenthesis is the class, and the second parenthesis is actually the cooldown, so that's just cooldown here. And we can do max cooldown. I put full down, great. Max cooldown field dot set int again, and that's class, and it is message dot max cooldown. So that's going to set the variable in the class correctly. So now we can return the values. So I'm just going to do the tile entity. So I need to do tile entity, te equals context dot get server handler dot, if you get the player entity, and we can then get the server world dot get tile entity at message dot parse. I know that seems really long-winded, but we've got the tile entity at the position. Now what we need to do is we need to check that the tile entity is not nothing. So if it is nothing, we're going to return. We're not going to do anything else. If the tile entity dot has capability, if it doesn't have the capability, mod capabilities dot capability worker from side message dot side. If it doesn't have it, we're going to return again. We're not going to do anything. And now our tile entity has everything we want. We can actually return the values. So what we're going to do is we need to actually register our messages to send them back to the client. So in network, in the package, we're going to have our packet handler. And what we're going to have is a private static int, which is ID, and that's equal to 0. and we're going to have a private static int called next ID, and this is just simply going to return ID plus plus, so the next ID. And I'll show you what this means, and we're going to just add public static void register messages, like so. And what we're going to put in here is the channel name, so string channel name. And now we need to actually have our channel, so it's a public static simple network wrapper, and we're going to call it instance. And in here, we're going to set instance equal to network registry dot, and it's instance dot new simple channel from the channel name. So we set up our channel, and we'll get back to this. We can now send messages off this channel. So if we do packet handler dot instance, and we can now send messages. So this will send a message to a player, which is what we're going to use. This can send it to everyone on the server, or everyone, which I don't recommend doing. Everyone around a point, everyone around in a dimension, and send it to the server. What we can do is just do a send to, and now we need to create a new message. So it's packet return worker, and we're going to put in the cooldown. And all these are message dot bits here. So we're going to pass these on. The cooldown is te dot, and we need to actually get the capability really. So iWork worker equals te dot get capability mod capabilities dot capability worker message dot side, like so. Control Shift O to import work. And what we can do is going to do work dot, it's an int, excuse me. It's worker dot get work done and worker dot get max work. So that's all of the data. We need to now just put in the player. So it's ctx dot get server handler dot player entity. So that's the player who sent it. So we've now sent it back to the client. We've updated the field. We need to now register our messages. So I'm just going to do server packets and client packets, so we can see which ones are which. And what we can do is instance dot register message, and we're going to use the class one. The message handler is packet. This is going to be sent to the server. That's the side the handler is on. So we put the side the handlers on. So packet get worker dot handler dot class. The actual message is packet get worker dot class. The discriminator is next, not entity, next ID, and the side that it's going to be handled on is the server side. And we can copy and paste all of this for the client one, except for we need to change it to client here. Need to change it to return worker, not get worker, and that will register our messages when we call it. So we need to now register our messages in the proxies, in the common proxy, and in pre-init we're going to do packet handler dot register messages. The channel name is just going to be mod ID, so reference dot mod ID, and like so we've registered our messages. We now need to sync with the server. So this is the most important part. So in here we're going to have a public static int, and it's going to be the cooldown, and it's also the max cooldown, the values that we're going to sync. And we're going to set both of these to 0 for now. So instead of doing te.get capability here, we're going to do we're going to show it. So cooldown add, and then I'm going to put a divide and the max cooldown, like so. that's going to draw it, but these aren't going to be synced because you need to tell it to sync. So we're going to have a public static int sync equals 0. Every time we draw, we're going to sync, not every time we draw, we're going to increase sync, so sync plus plus sync, and what we're going to do is we're going to sync with the server every 10 ticks. So that's every half a second. You don't want to do it every second because it's going to flood the server with loads of messages, and we do not want that. And what we're going to do, if the sync is 0, then we need to sync our message, our value. So we can do packet handler dot instance, there we go, dot send to server, and now we're going to send to server packet get worker. The pos is te.getPos. The side is this dot mc dot player dot get address is horizontal facing. The class name is this class name, so the way to get to this class, so it's the package, add the actual name of the class, which is GUI block breaker. Just as a note, if you had a class inside of a class, you would put a $sign to say we had the handler inside of this class. It would be $handler, but it's not. The cooldown field name is just cooldown, and the max cooldown field name is max cooldown. And like so, hopefully that will now sync our values with the server. So I'm just going to run it in debug mode for now. But hopefully everything now will be synced with the server. We'll have the correct data for our GUI. Okay, so I believe the error might actually be to something from absolutely ages ago. I wasn't supposed to remove the supers from here, and there's actually been a really long errors that I've had for a while. Okay, so the game is loaded up, so we should be able to go inside of our test world, and hopefully now the tilency will be working after that little error I made earlier. So I will have to break the tilency, of course, because otherwise it will not work. So we place you down. There we go. Don't know what that was about. Put it on, we don't get an error, and we do see when it's on it goes up to 50, when it's off it stops. Perfect. And if we get the other block breaker, the tier 1 block breaker, we should also see that that goes to 100. As you can see, because it's using the same GUI, it's updated to 50, it will stay at 50, then it will update, which is perfectly fine, and I didn't realise that was a thing. Okay. So obviously when these are both on, these will both go up, this will go up. And also, if I grab some efficiency book, efficiency 5 will do. As you know, efficiency will lower the cap, so we can actually now see what the cap is. In the next tutorial, we're going to be adding a visual way of seeing this cap. So, hold on. So that's really cool that we can actually now update with the server. Hopefully this is useful to you. So say you have some server data. Now a quick fix for this would have been to make so it updates the client as well. But tilency data should really be handled on the server side. So thank you for watching. Don't forget to like, comment and subscribe. I am out.